First problem. A reflex klystron is to be operated at frequency of 10 GHz with DC beam voltage 300 volts, repeller space 0.1 cm for 1 3/4 mode. Calculate maximum RF power and corresponding repeller voltage for a beam current of 20 milliamperes. Firstly, we will write given parameter values. DC beam voltage, notation V0, is equal to 300 volts. Beam current is notation I0, 20 milliamperes. Repeller space L, 0.1 centimeter, and mode is equal to 1 3/4. And frequency is 10 GHz. Solution. We have to find out maximum RF power and repeller voltage. Maximum RF power formula 0.398 multiplied with V0 and I0 divided by mode. After substituting the V0, I0 and N, we will get following equation. V0 is 300 volt, I0 is 20 milliamperes, 10 to the power minus 3 divided by N. Which is equal to 1.365 watts. Now we have to find out repeller voltage. Repeller voltage notation VR expression 6.74 into 10 to the power minus 6 multiplied with frequency in hertz multiplied with repeller space in meter, then multiplied with root of beam voltage value divided by mode N minus repeller beam voltage minus V0. Frequency is 10 GHz. Length is given in centimeter. As per expression, we have to convert to the meter. Point 1 into 10 to the power minus 2, which is equal to 10 to the power minus 3 meter. So N is equal to 1.75. V0 is 300 volts. Now I'll substitute all the values in the repeller voltage expression. 6.74 into 10 to the power minus 6 multiplied with frequency is 10 gigahertz. 10 to the power 10 into 10 to the power 9. Repeller space is 10 to the power minus 3 root of 300 V0 divided by 1.75 minus 300, which is equal to 667.08 minus V0, which is equal to 367.08 volts. Is the solution for the first problem. Second problem. A reflex klystron is operated at frequency of 5 GHz with DC beam voltage 350 volts, repeller spacing 0.5 cm for 3 into 3 by 4 mode. Calculate bandwidth over delta VR. Rate of change of repeller voltage is equal to 1 volts. Solution. We need to find out the bandwidth over delta VR is equal to 1 volts. We have the expression delta VR is equal to 6.7438 into 10 to the power minus 6 multiplied with the repeller space in meter, then delta F in hertz multiplied with V0 divided by mod N. N is given, that is 3 into 3 by 4, which is equal to 15 by 4. Repeller space should be in meter, here given in centimeter. Then V0 beam voltage is equal to 350 volts. So repeller space 0.5 into 10 to the power minus 2 in meter. I'll substitute given parameters in the expression delta VR. Delta VR is 1 volt, which is equal to 1 is equal to 6.7438 into 10 to the power minus 6 multiplied with repeller space is 0.5 into 10 to the power minus 2 into delta F in hertz. It's a bandwidth notation, multiplied with root of V naught. 350 volts divided by N is 15 by 4. Therefore, bandwidth is equal to 5.948 megahertz over delta VR is equal to 1 volts. Third problem. A reflex klystron is operated at frequency of 9 GHz with DC beam voltage 600 volts for 1 into 3 by 4 mode, repeller space length 1 millimeter, beam current of 10 milliamperes. The beam coupling coefficient is assumed to be 1. Calculate the repeller voltage, electronic efficiency and output power. Given parameters, beam voltage V naught is 600 volts, mode N is equal to 1 into 3 by 4, which is equal to 1.75. Repeller space 1 millimeter in meter is 1 into 10 to the power minus 3 meter. Beam current is equal to 10 milliamperes. Frequency 9 gigahertz. And beam coupling coefficient is beta 1 is equal to 1. We have to find out output power, repeller voltage, and efficiency. Solution. Output power is equal to 0.398 into V naught multiplied with I naught divided by N, which is equal to 0.398. V naught is 600 volts, I naught is 10 milliamperes, and N is 1 into 3 by 4. Therefore, output power is equal to 1.3644 watts. Repeller voltage expression is 6.74 into 10 to the power minus 6 into frequency in hertz multiplied with repeller space in meter multiplied with root of beam voltage divided by N minus V naught. Repeller voltage is equal to 6.74 into 10 to the power minus 6 multiplied with frequency is 9 gigahertz. 9 into 10 to the power 9. Repeller space is 1 into 10 to the power minus 3 meter multiplied with root of V naught is 600 divided by 1 into 3 by 4 mode is 1.75 minus 600, which is equal to 849.06 minus 600. Therefore, repeller voltage is equal to 249.06 volts. Now, we need to find out efficiency. Efficiency is equal to 0.398 divided by N, which is equal to 0.398 divided by 1 into 3 by 4, which is equal to 1.75, is equal to 0.2274. So efficiency in percentage is equal to 22.74%. This is the solution for the third problem. First problem. A transmission line has the following parameters: resistance 5 ohm per kilometer, conductance 0.5 micro mho per kilometer, inductance 2.5 millihenry per kilometer, capacitance 0.005 farad per kilometer, and frequency has given 1 kilohertz. Calculate characteristic impedance, propagation constant, phase velocity, attenuation constant, and phase constant. Solution. First one is characteristic impedance. Z0 is a notation. It is equal to root Z divided by Y. Root of Z is equal to R plus J omega L divided by G plus J omega C. So what is Z? Z is equal to R plus J omega L. So omega is equal to 2 pi f. It is equal to R is 5 ohm per kilometer plus J 2 pi f. 2 pi f 1 kilohertz 10 to the power 3 multiplied with L value. That is 2.5 into 10 to the power minus 3. 2.5 millihenry, which is equal to 5 plus 15.7 J. This is in the rectangular form. When we convert to the polar form, the Z0 is Z is equal to 16.47 angle 72.33 degree. Y is equal to G plus J omega C. G is 0.5 micro, that is 10 to the power minus 6, plus J 2 pi F. F is 1 kilohertz, 1 into 10 to the power 3 multiplied with the capacitance 0.005, which is equal to 5 into 10 to the power minus 7 plus J 31.42, which is equal to, convert the rectangular form to polar form, that is 31.42 angle 89.99 degree. Now Z0 is root Z by Y. Substitute the Z and Y value. Z is equal to 16.47 angle 72.33 degree divided by 31.42 angle 89.99 degree, which is equal to, when we divide 16.47 by 31.42, we will get 0.524 and angle 72.33 degree minus 89.99 degree is equal to minus 17.66 degree. So square root of 0.524 is equal to 0.724 and square root of angle minus 17.66 degree is minus 8.83, which is equal to Z0. So square root of angle theta is equal to theta by 2. Now propagation constant notation is gamma is equal to root Z into Y. What is Z? Z is 16.47 angle 72.33 degree Y is 31.42 angle 89.99 degree. When we multiply 16.47 with 31.42, we will get 517.48. angle 72.33 plus 89.99 is equal to 162.32, which is equal to square root of 517.48 is 22.75. Angle square root of angle 162.32 is 81.16 degree. Rectangular form of this answer is 3.5 3.5 plus J 22.48. Next, phase velocity. Phase velocity is given by Vp is equal to 1 by root LC, which is equal to 1 divided by root of L value. L is 2.5 milli, 10 to the power minus 3. Capacitance is 0.005 is given, so which is equal to 282.8 kilometer per second. Next, we have to find out phase constant and attenuation constant. Attenuation constant and phase constant. We know that what is the propagation constant for this given problem is 3.5 plus J 22.48, which is in the form alpha plus J beta. Therefore, I can write alpha is 3.5 beta is 22.48. Or I can substitute the given constant values for the formula beta, that is phase constant equation is omega root LC, where alpha is given by the expression half R root C by L plus G root L by C. Second problem, a certain transmission line has 75 plus J 0.01 ohm and is terminated by a load impedance ZL equal to 70 plus J 50 ohm. Calculate reflection coefficient, transmission coefficient, verify T square is equal to ZL by Z0 into 1 minus gamma square, verify transmission coefficient equals algebraic sum of 1 plus reflection coefficient. Solution. Given parameters are z del and z naught. ZL is equal to 70 plus J 50 ohm ZL is equal to 70 plus J 50 ohm and Z naught is 75 plus J 0.01 ohm. We have to find out reflection coefficient. The notation for the reflection coefficient is gamma and given parameters are ZL and Z0. Therefore, there is a reflection coefficient equation using impedances is ZL minus Z0 divided by ZL plus Z0. Now substitute the ZL and Z0 to the equation. Reflection coefficient is equal to ZL minus Z0. ZL is 70 plus J 50 minus Z0 is 75 plus J 0.01 ohm divided by ZL plus Z0 70 plus J 50 plus plus 75 plus J 0.01 which is equal to, after subtracting we will get minus 5 plus J 49.99 divided by, after addition we will get 145 plus J 50.01 which is equal to, if I convert to the polar form, then 50.24 angle 95.71 divided by 153.38 angle 19.03. So now divide 50.24 by 153.38, then we will get 0.33 and angle 95.71 minus 19.03, we will get the angle 76.68 degree, which is equal to reflection coefficient. The rectangular form of this answer is 0.08 plus J 0.32. Transmission coefficient equation: 2 ZL divided by ZL plus Z0, which is equal to 2 into 70 plus J 50 ohm divided by ZL is 70 plus J 50 plus 75 plus J 0.01, which is equal to 140 plus J 100 divided by, after adding ZL plus Z0, 145 plus J 50.01. Convert the rectangular to polar form. In the numerator we will get 172.05 angle 35.54 degree divided by 153.38 angle 19.03 degree. 172.05 divided by 153.38 is equal to 1.12. Angle 35.54 degree minus 19.03 degree is equal to 16.51 degree. Convert to the rectangular form. 1.07 plus J 0.32. Now we have to verify right hand side equal to left hand side. Square of t is equal to ZL by Z0 1 minus gamma square. Consider now ZL by Z0 1 minus gamma square. Substitute the values. ZL and Z0 are given. Gamma we got by the equation ZL minus Z0 divided by ZL plus Z0. Therefore, ZL is 70 plus J 50 divided by Z0 is 75 plus J 0.01. 1 minus gamma square is 0.33 angle 76.68 square. +70 plus J50 polar form is 86 angle 35.54 degree divided by 75 plus J 0.01 polar form is 75 angle 0 degree. 1 minus square of the 0.33 angle 76.68 is equal to 0.1089 angle 153.04 36 degree. Eighty-six divided by 75 is equal to 1.146. 35.54 minus 0 is equal to angle 35.54 degree. Now 1 minus 0.1089 angle 153.36 degree. First the 1.1089 angle 153.36 degree is converted to the rectangular form. We will get minus 0.097 plus j 0.05. From previous line 1.146 angle 35.54 degree, and simplify the previous line in that 1 minus of minus 0.097 plus j 0.05, we will get 1.09 minus j 0.05. Now convert the 1.09 minus j 0.05 to the polar form. We will get 1.09 angle minus 2.6 degree. ZL by Z0 1 minus gamma square is equal to 1.46 multiplied with the 1.09, which is equal to 1.25. 35.54 degree minus 35.54 degree plus minus 2.6, that is equal to 33 degree. We got T is 1.07 plus j 0.32. Square of this answer is square of T is 1.04 plus j 0.68, which is equal to 1.25 angle 33 degree. Therefore, I can say that T square is equal to ZL by Z0 1 minus gamma square. Now we have to verify transmission coefficient equals algebraic sum of 1 plus reflection coefficient. So 1 plus the reflection coefficient we got as 0.08 plus j 0.32 value. So which is equal to 1.08 plus j 0.32. Which is nothing but the value what we got 1.07 plus j 0.32. Right hand side is equal to left hand side. Third problem, a transmission line has characteristic impedance of 50 plus j 0.01 ohm and is terminated by a load impedance of 73 minus j 42.5 ohm. Calculate reflection coefficient and standing wave ratio. Solution. First we will write given parameters. Z0 is equal to 50 plus j 0.01 ohm. ZL is equal to 73 minus j 42.5 ohm. Now to find out reflection coefficient, notation gamma is given by ZL minus Z0 divided by ZL plus Z0. ZL is equal to 73 minus j 42.5 ohm minus Z0 is 50 plus j 0.01 ohm. Now ZL plus Z0, 73 minus j 42.5 plus 50 plus j 0.01 ohm. After simplifying previous line, we will get 23 minus j 42.51 divided by, after adding ZL and Z0, we will get 123 minus j 42.49. Now convert rectangular form to polar form. In the numerator we will get 48.33 angle minus 61.58 degree. In the denominator 130.13 angle minus 19.06 degree. Therefore, reflection coefficient 148.33 divided by 130.13 is 0.37 minus 61.58 degree minus of minus 19.06 degree is equal to minus 42.5 degree. This is the reflection coefficient. Now what is the SWR? Standing wave ratio. Notation is 1, notation is rho and is equal to 1 plus magnitude of reflection coefficient divided by 1 minus magnitude of reflection coefficient, which is equal to 1 plus magnitude of the reflection coefficient is 0.37 divided by 1 minus 0.37. Therefore, reflection coefficient is equal to 2.17.